Okay, problem number 6. We've got a rational function we need to integrate. We look at this thing, and one of the first questions you got to ask yourself when you see a ratio of two polynomials is, can you factor the denominator? If you can, then partial fractions are probably going to work for you. If you can't, then something else may be going on. And there are also special cases where you've got things like arctangent and all that. But one of the first things to do, look at this. If this factors, very likely it's going to fall into one of these categories. Okay, so what can we do? Well, difference of squares, that factors to this, no problem. And then we do our setup. This is what we call our setup. And basically what we do is we take these factors in the denominator and spread them between two fractions and put a and b over the top, or ABC, or whatever is called for. And yeah, we're ready to go on. Now, there's two ways to proceed from here. You could multiply through by this denominator. You'd get cancellation and then solve for the answer in a normal sort of way. Or you could use the cover-up or knockout method. And I want to use the knockout method. In fact, the main point of doing this whole problem is to show you the knockout method. Okay, how does this work? Well, once we're in standard form, we say, okay, I want to solve for A. The way I'm going to do that is pick a value of W, okay, from this denominator. Pick a value over here that would make this 0. In other words, I'm going to cover up, I'm going to knock out this factor. Well, that will happen when W is equal to 2, because 2 minus 2 is 0. That knocks this factor out. Now, to get A, all I have to do is plug 2 into this equation. Don't do anything with this denominator. You're going to solve directly for A. So A is equal to a minus 8 2 times 2 minus 5 divided by, put in a 2 here, 2 plus 2 is 4, and this equals to minus 16 minus 5 minus 21 fourths. That's done. Now, the second situation, here we've got our I'm going to do it now and solve, in this case, for B. Once again, it's exactly the same. In other words, I need to now knock out this part. How am I going to knock out this part? By setting W equals to a minus 2 now. Minus 2 plus 2 is equal to 0. This is covered up. This is knocked out. B now is equal to this term right here. So we get B is equal to minus 8 times quantity minus 2 minus 5 all divided by minus 2 minus 2. And this is going to be equal to 16 minus 5, which is 11, over a minus 4, which is equal to a minus 11 fourths. So we have B and A solved for. We go back and plug into this equation and integrate. That's going to be pretty easy to do. We have minus 21 fourths, which is A, over W minus 2 minus, well, I guess I should say plus here before we make our conversion, minus 11 fourths over W plus 2. That's just rewriting this right up here. And of course, we're needing to integrate this like that. But this is all going to be pretty easy. These things just pull out. We can kind of write this as the integral of minus 21 fourths times the integral of 1 over W minus 2 minus 11 fourths integral of 1 over W plus 2, and of course a couple of dW's in both of these. And that is very easy to solve. It's just minus 21 fourths natural log W minus 2 minus 11 fourths natural log of W plus 2 plus a constant, and there's our answer. The answer really wasn't in doubt. It was all a matter of correctly doing this cover-up technique. And of course, we could have alternatively multiplied both sides of the equation by W minus 2, W plus 2, and W minus 2, W plus 2, and W minus 2, W plus 2, and we would have got cancelization here, 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 and here, and then we would have minus 8W minus 5 equals A times this, B times this, and solve in a more conventional way. It's exactly the same in terms of getting results. It's just quicker if you could apply the knockout method or the cover-up method. On the other hand, if you screw it up, you might make a mistake.